Elon Musk and NASA unveiled a light-speed engine quicker than anything previously seen in the aerospace industry. NASA and Musk have been collaborating for a while, following years of testing with the same objective of reaching the furthest reaches of space. A step closer to their objective has been made with the successful testing of this new engine, but what makes it unique from previous engines? After surviving the meteorite adventure, can it arrive safely? Here are a few justifications for why many scientists have differing perspectives about the potential uses of the new light-speed engine. Welcome back to another exciting video from Informed Now. Today's video is about Elon Musk and NASA finally reveals new light-speed engine that defies physics. Before we start the video, please like, subscribe, and press the bell icon. The difficulty of space travel. Elon Musk wants to make it possible for people to visit Mars successfully by 2050. Elon has a track record of delivering results. Thus, NASA is working with him to achieve that. Space travel has presented several challenges, most notably a voyage to Mars. The average distance between the fourth planet in our solar system and Earth is 140 million miles. So, to reach Mars, a rocket would need to travel at 15,000 miles per hour for at least 7 months. The primary fuel used by current technology is methane rather than kerosene. This fuel must be prepared and added to the rocket before taking off for a successful flight. However, how much fuel, room, and fuel would be required for a rocket that consumes 11,000 pounds of fuel every second day? The response is significant. This is considered when developing a rocket to perform such a risky task. When developing a spaceship, voyagers must balance the craft's weight with the most efficient use of fuel. View the Starship that is currently on a special mission to Mars. Most compartments that contribute to the ship's weight are used to store fuel and supplies, with only a small portion designated for them. The spacecraft is 120 meters above the surface and is powered by 33 Raptor engine, each of which has a 500,000-pound thrust capacity. Although the engine is designed to be fuel efficient, it will be difficult to have enough fuel for a voyage to and from Mars. This explains why the only successful Mars missions have used robotics and smaller rockets, as there was no need for people, additional fuel, or supplies for the entire trip. Using aerobraking to insert the rocket into Mars safely would involve adding more fuel to an already heavy vehicle. Elon Musk, a space enthusiast, is aware that the road ahead will be challenging, as he mentioned. The potential of the new engine will make such a journey risky, uncomfortable, difficult, and taxing, but it will be worthwhile. Chemical rockets are typically built on the third law of motion, which stipulates that the action and reaction forces are equal in strength and oppose in direction. According to the Falcon hypothesis, the present Starship and the Space Shuttle use fuel like methane and oxygen in a combustion form to generate thrust. By passing hot exhaust gases, steam, and water through a nozzle, this light-speed engine aims to do something new from the traditional practice of quickening liftoff. To move space, no fuel is needed. According to relativity, objects lose mass as they approach the speed at which they move. Ions are enclosed in a loop, accelerated to low speeds, and then their velocities are changed just enough to change the mass of the ions to create the desired result. The ions will move back and forth in one way through the engine. The engine will develop a helical structure and resemble a drawn-out thread. The only moving parts will be the ions in the electromagnetic drive's electric and magnetic fields. This light-speed engine intends to provide thrust without the need for disputed propulsion technology. According to David Goodwin, any rocket can travel into space more quickly and efficiently than any other propulsion system. It might produce a propulsion system that is effective enough to reach speeds of less than 1% of the speed of the vibration from electromagnetic waves or ions that can be concentrated in one direction. The idea of providing propulsion without fuel is familiar, though. In 1990, Goodwin directed a NASA study that broke new ground in propulsion physics, intending to develop propellant-free propulsion. Rogers developed the first device in 2001 that illustrated the idea of a reactionless drive. If the new light-speed engine holds such enormous promise and can assist humanity in achieving its goal of visiting the higher heaven, why should scientists study it? Since the inaugural demonstration in 2000, engine scientists from the US, the UK, and China have demonstrated the limitations of electromagnetic propulsion. Some contend that there is a better time to celebrate, however, because it is still being determined how the propulsion will be used. Since the previous experiments were not carried out in a vacuum, producing energy in a quantum vacuum is impossible. Measurement mistakes and ambiguity may result since particles can only be ionized after the project starts. Considering even a small influence of the guidance to be significant, we need to consider how much it will cost to run. Using an M drive would be highly time-consuming and expensive. It has already gotten $5 million from NASA, and the exact amount needed to make improvements is unknown. Moreover, rocketry can only gain momentum with a comparable trigger. In addition to breaking Newton's third law of motion, earlier attempts to do this violated the law of momentum conversion, which states that an object's momentum must remain constant in the absence of an external force. The concept of momentum conversion is well understood in physics. Thus, it isn't plausible that this new engine can go beyond the boundaries of accepted physics that apply to all known forms of motion. The rock might even be able to resist media attention. Proper ordeal: a meteorite reaches the Earth's atmosphere at a speed of 120,000 miles per second. It travels through the Earth's atmosphere and ignites violently before falling to the ground. We now know that a meteorite is a chunk of cosmic rock that can withstand impact. Can a rocket propelled by an M-drive endure the same impact? If it travels at the speed of light, it will burn up when it returns, which is a terrible conclusion. Additionally, during earlier Mars landings, the descent had to be stopped by firing rockets at the surface. If the new rocket won't be using engines, how will it successfully land? The proper propulsion system must be installed on the spacecraft. Since the atmosphere on Mars is so thick, the rocket will burn up upon entry. To the joy of detractors, a team from Dresden University led by Martin Tamer discovers a flaw in the new light-speed engine. The experiment showed that the push might not have been caused by the drive but rather by some other electromagnetic interaction. The study asserted to have discovered important gaps in past studies that suggested it might be challenging to construct a working light-speed engine. None. NASA has been successful in proving the doubts of other researchers in M-drive. It was put to the test at EagleWorks Laboratory by a group of scientists conducting a NASA-funded investigation to examine how it may function in deep space. These experiments showed that a thrust-to-power ratio of 1:4, which was higher than any predicted prediction for the drive, was practical, and fresh avenues for debate were made available. Space. According to Rogers, the well-regarded negative tests were based on a subpar design and should be taken with a grain of salt. Rogers also defended the M-drive. Given the diverse opinions and findings of the test, it is impossible to completely rule out the drive as a potential for space travel. The development of the engine will undoubtedly require the whole range of Elon Musk and NASA's creativity and experimentation. Even yet, when it's all said and done, it will be one of the most important steps taken by people to become a multiplanetary species. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.